Did you know that if gravity were slightly more powerful, the universe would collapse into a ball?
I did not.
Also, if gravity were slightly less powerful, the universe would fly apart and there'd be no stars or planets.
Where are you going with this, Sheldon?
It's just that gravity is precisely as strong as it needs to be. And if the ratio of the electromagnetic force to the strong force wasn't 1%, life wouldn't exist. What are the odds that would happen all by itself?
Why are you trying to convince me to believe in God? You don't believe in God.
I don't, but the precision of the universe at least makes it logical to conclude there's a creator.
As Sheldon just mentioned in this clip that probably the majority of you just watched, the universe is precisely and perfectly created. And we question, is it really doable and believable that there are thousands of other ones out there made with the same precision? And for this, I want to ask you guys, what does really push us to believe that there is another parallel world or universe or what we call Hezar multiverse?
I reckon because it is the appeal of an ideal world where we have second chances, where things turn out well, or maybe an alternate reality where the acceptance rate at Harvard is not 4.7%.
I think 3%. Mm-hmm.
It's for the COVID period, it was 3% actually. Okay. And I have a Lamborghini, for example, or at least I just plug in my cord, my USB cord in the computer from the first trial. Or actually, guys, if this was really real, I want to switch off with my copy over there and fall in love with you guys all over again.
Oh.
Put away your phone.
They're too lazy.
Oh my God, they're too sensitive.
Yeah, stupid.
Rude.
Oversensitive.
What is insensitive? They're too introverted.
They can't get rid of their electronics.
Invasive?
They're hard to define.
Gen Z is talking.
The parallel universes theory, or what we call the many-world theory, just transformed from being the most captivating science fiction movies topic to being proved by science. And we have scientists working hard to really make it such a thing. And here we have different scientific concepts that try to support it, such as the Big Bang, the string theory, and quantum physics.
Yeah.
So I would like to dig deeper into this topic, but before, let me introduce myself as Gen Z's host, Sireen bin Ammar, and who's talking to you from Radio Web Free Voices Akuda station.
Make me a radio and turn me up when you feel low. Make me a radio and turn me up when you feel low. This melody is meant for you.
As they always interrupt me, I would love to give them the opportunity to introduce themselves. And so we have...
Hello, it's me. Hi everyone. So it's me, Iman Misawi, and I'm so happy to be here. And I hope you had a wonderful week, and I hope you well. So yeah,
Thank you, Iman.
Greetings, everyone. I've been really excited about this session, and I've been in another world completely. So, greetings from my world to yours. I'm Ahmed Amin. This is my second time here, and I'm here to do my best.
And we're glad you're here. And then, last but not least,
And here I go again, your usual co-host, Hezar العريف.
energy's up.
Oh, okay.
Okay, so for now, we're trying to start our real conversation. And for that, I need someone brave enough to start tackling the first one, which is the Big Bang.
So bravery itself is talking here. What if I tell you guys that the Big
Hold
Bang?
on. Which Big Bang are you going to talk about?
The classic Big Bang.
Then let me mention to our listeners that before the 10 to the power of minus 32 seconds had passed, our universe had exploded to 10 to the power of 26 other universes, even bigger than its original size. And this is even before the actual expansion of matter and what scientists use it to call the cosmic inflation. And after that, let me help you carry on your introduction.
Thank you, Sireen. So, what if I tell you guys that the Big Bang wasn't an explosion? In fact, it was an expansion, because the most common idea is that it was an explosion, and after that, the universe started creating. So the entire universe started stretching everywhere all at once. It was like a very tiny particle then that started expanding into the size of a football, then to our whole universe. It extended to everything simply because it has no boundaries, like we can say, outside of this universe or something. So
makes sense, yeah.
Yeah, due to the hot and the dense environment out there, the energy manifested itself in particles that exist in a very short period, like of time. Gluons formed there, and they created pairs of quarks. They interacted with each other. Guys, I'm trying to give you a very simple explanation, so you
this
have
is simple. Just a
these are the quarks and the gluons. They are very tiny. They are even tinier than the atom. So yeah.
It's even hard to explain it since it's hard to observe it.
Yeah,
really.
since it's in quantum physics. So
it's strange, and
it's fine if you don't understand it, because simply you didn't study it or you had no idea about it. So yeah. As I said, so these gluons, they created the quarks, and these pair of quarks interacted, and they created gluons. And this is called the cycle of quarks. And after creating the cycle of quarks and converting them back to energy, and they suddenly stopped, they stopped, and they formed and started forming the atoms, and these very small particles.
Yes.
And before the atoms, they created the hydrons, the protons, and the neutrons.
Disclaimer?
A disclaimer that all of this happened in just 1 second, like
a fraction of a second or 1 second.
In 1 second, the neutrons and hydrons and electrons, all of these created in 1 second. Yeah, since the start of the creation of this
matter.
Yeah,
this whole thing.
Yeah. So the decrease in temperature made the perfect atmosphere to form the first atom of hydrogen. When I say the degrees in temperature, it's still hot there. I'm talking like a billions of degrees, like in Celsius, of course.
Yeah.
So it's still hot, but the expansion of the universe made it colder. So atoms formed out of hydrons and electrons with under the great amount of pressure of gravity, and after millions of years of the clamp of the atoms of hydrogen, they formed stars and galaxies, because when there was only hydrogen, there was no light. Also, we have nothing to do with the light, since there's no one there to see or yeah,
makes total sense.
Yeah. So after this, finally there was a light after the pressure in the clamp of the atoms of hydrogen, the visible light exists. So let me explain this, how it happened. Because the radiation of the stars and galaxies dissolved like the stable atom of hydrogen to form the plasma, which is necessary for the visible light to pass through it. So here it is, how the whole universe started. So let's go to the string theory, I think, now.
Yeah, so Iman, thank you so much for you trying to explain it, because guys, I really hope you appreciate that it's not easy to go through these things. Like it is
it's hard to fathom.
Yeah, and before
even physics didn't find the solution for
even
this.
the simplest way to explain it. So we're trying hard and hope they appreciate that.
Give it in a simpler way.
Yeah, and before we head to the next theory that I don't know which one of you guys is brave enough to introduce it, I would love to listen to a song that Hezar just chosen, which is about parallel universe.
What would it be like if I was with you tonight? Would you hold me? I can see behind your smile that your thoughts are running wild. Oh, just hold me. The records on our phone show there is nothing wrong, it's normal. So why do things align to conclusions in my mind? Is that normal? When you'd walk me places and we'd stand outside, the rain in our faces, but only goodbyes. Those stare too long moments we let pass us by. When you got me wasted on so many nights. In a parallel universe, would you always want to put me first? In a parallel universe, oh, oh, oh. In a parallel universe, you always want to put me first. In a parallel universe, oh, oh, oh. In a parallel universe.
Back to our episode, and back to us going to be tackling the string theory, and it is okay. It was hard enough to guess it though.
So as Iman mentioned before, the singularity that everything started with, it created all matter. Basically, our universe consists of atoms, and in the past, they were regarded as the smallest building blocks of matter. But later on, we could decompose them sort of into smaller particles, and finally we reached elementary building blocks, which are like quarks, bosons, and leptons. To observe a particle or to observe something generally, we need light to reflect off of it so that we can see it. However, these particles are so small, unimaginably small, that even electromagnetic waves, they pass through them. We cannot see them. And
this is why, Ahmed, actually they mentioned the hard to observe kind of word. Because we're talking, sometimes we feel like we're talking nonsense to people.
Exactly.
So yeah, carry on.
So the quantum world is really different from ours, so we cannot observe. Even electrons are hard to observe. We only see a halo, sort of, I don't know, foggy thing. We cannot observe them totally. So we try to really condense the wavelength of our electromagnetic waves so that we can observe these particles, but they just bounce off of them. So we cannot see them. We can only see their sort of effect, and it's really really almost negligible.
Okay, and fun fact, Amin, once I started learning about quantum physics, I was calling it the wave physics, because it's actually the main resource of talking strings, like a guitar, a violin, and since we have a ukulele here.
So just a disclaimer, guys. If our listeners find themselves like they don't understand anything, it's totally fine, because what we are talking now, it's like
absurdity.
we are talking about theories here. First of all, also we are talking about things that based on like quantum physics, which is like something some people don't have even an idea about it,
Or
about
some
it existing.
knowledge
Like,
about it.
yeah. So yeah, try to make it like a story or understand it like a fairy tale or anything, just to make it simpler so you can understand it. And yeah, so you can carry on.
So back to the observance notion. We talked about how we cannot observe them, and it comes back really to the Heisenberg uncertainty principle, which dictates that we cannot know the exact location of a particle. We cannot, and thus we cannot observe.
I'm kidding.
Thus we cannot observe them. So in quantum physics, every force is carried by some kind of particle, which applies to everything we know so far, except for gravity. However, according to Einstein, gravity is related to the geometry of space-time itself. Like,
we find Einstein in every
he's a polymath.
It's everywhere.
So basically, these particles exist in this space-time continuum. Yet we cannot apply regular geometry in the quantum physics world. So we cannot measure distances precisely, and these particles are so really small. So this precision is really needed.
You're kind of about to answer a question I was going to hit you with, which is there a scientific something that did scientists really prove it? Do you know if?
I think it's yet to be confirmed. All the theories are unconfirmed, actually.
Yet in quantum physics, we cannot apply regular geometry, so we cannot measure distances precisely, and this precision is really needed because these particles are extremely small and unobservable. So scientists are trying to create or to invent a new particle, since regular geometry is not compatible with the quantum physics world, and they try to invent this particle that transfers the force of gravity.
Okay.
However, the maths didn't check out, and it's been a really huge problem. So scientists theorize the string theory, which says that particles can be represented as one-dimensional entities or simply just lines, or we can say strings.
So, Amin, we're talking dimensions, we're talking strings. What is this really about?
According to the theory, all particles are different modes of vibrations of the same string, like guitar or violin or ukulele in this case. So it's the same as instruments and notes, which also includes gravity, which is our problem here. So string theory aims to unify all fundamental aspects of the universe, which will help us understand a lot of stuff. Like, they are unfathomable. We cannot understand them, like black holes and stuff like that.
So, sorry, Ahmed, to interrupt, but I think there is a big question here, which is this scientifically proven or something like we need proofs for this, for what you're talking about?
So this theory, like the maths for this theory, they require 10 dimensions for it to work and check out with itself. But our universe has only 4, like 3 spatial ones, length, depth, and width, and 1 temporal one, which is time. So these scientists tried to calculate in model universes and tried to get rid of the extra 6 dimensions to get equations that describe our own, which no one to this moment succeeded at really. However, this theory will really help us understand the universe a lot better. It's really eye-opening. I mean, it helps us a lot. It'll be a breakdown. So because of this mathematical problem and the non-existence of experimental predictions, the string theory, it stays still a theory.
Okay, makes sense.
So there are no scientific proofs.
For now.
There are actually no experiments that proves this, but they are kind of, I think, scientifically proven, but they just need...
Approved of, or like, not proven, right? The scientists approve of them.
Okay.
Okay, so guys, before jump into the third part, I would love for you to enjoy. I would love for you to enjoy some tasty music that again Hezar chosen for us for today, and let's have fun.
I let you get away just like that, I relapse. Helplessly I relapse. In a parallel universe, everything in reverse. Maybe you could be mine. In a parallel universe, where time is cat to us, maybe we would be alright.
Back again from a lovely trip. Since she's the one always choosing us some crazy and music, I would love to ask her, are you ready to hit the third model?
Yeah.
She has no choice.
I'm always ready. Okay. For me, I will be talking about the quantum physics model of this theory. The idea of parallel universes that you guys didn't mention actually goes back to 1954.
So you're talking history here.
Yeah.
Yeah.
It's like a ridiculous fact. It's when we as Tunisians were busy getting rid of colonization.
Okay.
Unless otherwise we might have been the ones who to come with this crazy idea. I mean,
yeah.
So it was an American doctoral Princeton student named Hugh Avard III who came with it. He said that there are universes that look exactly like ours. And but they are so far away from ours.
I think the distance from a parallel universe to the next parallel universe is 10 to the power of 10, all to the power of 29, which equals in math 10 to the power of 290.
Okay,
you stole my mic there.
Hold on, 290 light years. We're talking about light years as a unit, so you can understand.
I can't even get to realize the number, guys.
Okay. He proposed that all of these universes are connected in a way or other, and that each one diverge from the other. Actually, it's just our other copies take different decisions, and so different outcomes. This is why we don't have the same fates.
Sorry, Hazar, I have a question here. Was it he thought about it, or he had some theories, scientific ones?
There is no yet. There is no scientific proof. It's all about theories. Yeah,
we're still talking theories.
Yeah, he thought about that. It could be possible.
Yeah.
So
okay.
he.
Now
since he actually believes that in parallel universes everything goes in reverse.
So you're playing Uno.
we might be together in other universe, but
when they having the same relationship.
Yeah.
I get it. Guys, just
but we exist. Our copies over there. This is
they just took another decisions, another choices in their
different
life.
paths,
yeah,
different other paths.
Yeah.
Okay.
And this interpretation led us to think. I want you guys to have a reflection moment.
Okay.
If dinosaurs are extant in our universe, maybe they are living in other universes, don't you think?
Yeah, maybe they're even dealing with humans and they're having great relationships.
Maybe they are pets or something.
Or maybe we're using dinosaurs as a mean of transport to reduce pollution.
Or even we might be not existing in there.
Infinite
we might be
possibilities.
the extent race.
Yeah.
Okay, but Hazar, don't you see that it's all about pure philosophy here? Why don't we talk more science?
Okay. So to explain things in a more scientific way, we have to mention Copenhagen explanation.
Yes.
Copenhagen explanation by Everett's professor, the Danish physicist Niels Bohr, who proposed that a quantum particle does not exist in one state or another, but in all of its possible states at the same time. And this is what we call the superposition phenomenon.
But we see it has taken only one state. How is that possible?
Actually, this is all about observation, because observation pushes the particle to appear for us as one of its states. This is the simplest way to describe the whole theory.
So, Hazar, sorry, you talked about version in these universes are diverse.
Yeah. At first, I talked about Everett, who believed that parallel universes are appearing by pure divergence.
Yeah, and now you're talking superpositions.
Yeah, but his professor, actually, Niels Bohr, believed that this is all about superposition phenomenon, and all the observation is the act to push the particle to choose one of its states to appear for us.
Okay. So then, guys, we come up to explain in theories, and I would love to mention some experiences or some stories we heard in our real life. Maybe one about the man in Tokyo who they found in an airport and who was mentioning he's coming from a country between France, and Spain, and then when they were checking that country, it didn't exist, and after a period of time he vanished. The German girl who fell asleep, and then she was she disappeared and vanished, and they've been spending 3 days looking for her and stuff, but then she wake up in her room. She told them that she just fell asleep, but she had a weird nightmare, and she saw some different people and weird ones who were telling her weird stories. And also we can talk about Richard, an American army agent who were traveling and stuff, and he found a place, a weird one. And I would love before to carry on his story to let you guys listen for a bit of his interview. He said,
okay.
Today, an area as big as the United States that's never been seen by a human being. And that's beyond the pole on the other side of the South Pole from Middle America. And I think it's quite astonishing that there should be an area as big as that unexplored.
That's a tremendous
So
challenge.
there's a lot of adventure left down at the bottom of the world.
Well, Admiral, do you hope to see that?
I do.
Well, Admiral, would you say that since you've been to both the extremities of Earth, are these expeditions to such far-off places, are they getting easier because of modern techniques, or is danger still close at hand?
So Richard's story was a little bit weird because he didn't mention that after that happened to him, he wrote it in his diary, and his daughter found that and shared it after he died. So we see that he wasn't trying to tell us this story on purpose, and I would love to ask you guys to keep on looking and dig deeper into these kind of stories. And for that, I would love to say that our episodes just came to an end, but I'm asking you guys, all of our listeners, to give us your comments and feedbacks about what we said about these theories. What do you think of or believe in? And I would love to thank our technical team for their amazing efforts, Ryan, Ayari, and Yassin Bouslema, for recording this, helping us with pictures and videos. I would love to thank Mrs. Monet and everyone helping us to record this episode. Thank you, dear co-hosts, for your help, and I love you so much. Thank you.